Hello, algebra students. Today we're going to take a look at simplifying radical expressions. Simplifying a radical expression means we want to rewrite the expression so that there are no fractions under the radical sign. And so that no radicals are in the denominator. So we don't want like a cube root or square root, mostly square roots are what we're going to work with, and we don't want those in the denominator. And that no integral radicand has a square factor greater than 1. Now it's really fancy words for what we're going to do is pull out any perfect squares. So anytime we can take the square root of a perfect square, we're going to do that. So the first thing I want to address is that this won't, like as the questions get more complicated, there won't be only one approach. So the more complicated the question in math, of course, the more ways you can approach it. And so I'll show you a method or sometimes two, but you might have another way of approaching it. The important thing is that we're able to get to the same simplified answer. So when we're simplifying 3 root 2 times 4 root 18, we want to combine them with multiplying. So I'm going to first multiply my coefficients, and 3 times 4 gives me 12. And then underneath the radical sign, we have 2 times 18. So I'm writing that out. You don't necessarily have to write it out, just kind of taking you through my thought process. So that's going to become 12 root 36. Now 36 is a perfect square, and this is where we're talking about we want to pull out any perfect squares. Now I know 36 is a perfect square because I can get it by multiplying a value by itself, 6 times 6. So because we have 6 times 6, I'm going to actually take the square root of that. The square root of 36 is 6. And so I'm going to pull that perfect square out of the square root sign. And so that becomes 12 times 6. The square root of 36 is 6. I pull the perfect square out. And so my final product is 12 times 6, or 72. So in the next one, we have fractions under the radical sign. And so we want to simplify it so we end up with not having fractions under the radical sign. We can still have a radical sign, but we don't want complete fractions under there. And so I'm going to start by combining them with multiplication. So I'm just going to put them together. So that becomes 3 times 14, the square root of the whole quantity, 3 times 14 over 7 times 27. Now, again, this is not the only method, but I like to break mine down into primes so that I can see the building blocks. This also helps when you're not dealing with a calculator, and so that you can see the little numbers instead of dealing with the bigger products. If we were dealing with the product, we would get 42 in the numerator and 189 in the denominator, and that's fine, but it's a little bit harder to see the building blocks of that, I think. So I'm going to break my numerator into its primes, and that's 3, and then 7 breaks into 14 breaks into 2 times 7. And then I have the 7 from the 3 sevenths, and my 27 would break into primes as 3 times 3 times 3. Now what this allows me to do is to see where I can cancel things out. When you have 3 over 3 in a fraction, that's just equal to 1, so we can cancel it. And the 7 over 7 can also cancel. And so then what we're left with in this right now is the square root of 2 over 9, or 3 times 3. And again, you could leave it as 3 times 3. But 9 is a perfect square, so I can take the square root of that out. And so what I have is the square root of 2 over the square root of 9, or the square root of 2 over 3, because I want to take the square root wherever I can. I'm trying to pull out those perfect square roots. So now I don't have an entire fraction under the radical sign, and I've pulled out any perfect squares, and I don't have any radicals in the denominator. So that's my simplified radical, root 2 over 3. For the next one, you can see that we have a radical sign in the denominator. And one of the ways to get rid of the radical sign in the denominator is by simply multiplying by a fraction equivalent to 1. You can multiply any fraction by anything by a value of 1, and it doesn't change the value. We just want to manipulate what that value of 1 looks like. So anytime you have a fraction with the same value in the numerator and denominator, that is equal to 1. So I'm going to use that property to get rid of the radical sign in the denominator. Because I can have a value over itself equaling 1, it doesn't change the value of the fraction here if I multiply by root 5 over the square root of 5. Because this fraction is equivalent to 1. So if I multiply here, it changes the way things look, but it doesn't change the value. So this becomes 3 times root 5, or 3 times the square root of 5, and then the square root of 5 times the square root of 5, I can write that all under the same radical sign. You don't have to go through that step, just trying to take you through again the thought process. So that's 3 root 5 over the square root of 25. And 25 is a perfect square, so I can take the square root of it. The square root of 25 is 5. So by multiplying the square root of 5 times itself, I kind of get rid of the square root bar. And then in the numerator, I have 3 root 5. So now I don't have a fraction under a radical sign. There are no radicals in the denominator, and I've taken out all my perfect squares. So that's simplified. So we're going to practice again. I have the square root of 7/8, and I can break that down into the square root of 7 times the square root of 8. I could immediately multiply by the square root of 8 in both the numerator and denominator, just like the last one, to get rid of the radical sign in the denominator. Multiplying the square root of 8 times the square root of 8 would just give me 8. And the square root of 7 times the square root of 8 would give me the square root of 56. Now that's not quite simplified yet. I would want to break it down, because 56 can be broken down. And this is where it might be easier to deal with primes first. So the square root of 56 can be broken into 7 times 2 times 2 times 2. And hopefully you can see how that relates to the 7 times 8. And then, of course, we have in the denominator our 8. Now, in the numerator, we have a perfect square of 4. And we can take out that perfect square. That would give us 2 root 14 over 8. Now, 2/8 can be simplified to 1/4, and so that would be 1 square root of 4 over 4. I'm sorry, 14. That should be a 14. And I don't have to write the 1. So this can be simplified as the square root of 14 over 4. Now again, that's not the only way to go through that. There are other ways. If you would have started with something else and you want to try that and bring your questions in, you certainly can. For the next value, we want to simplify, and so we've got 9 root 3 over the square root of 24, and again, I really do like to typically break them down into primes so I can kind of see what blocks I'm dealing with. And so I want to think about breaking 24 down into its prime, and if you need to, then like off to the side, do a little factor tree. So like 24 could be 6 times 4, and 6 breaks down into 2 times 3, and 4 breaks down into 2 times 2. So however you break it down, 24 breaks down into 3 factors of 2 and a factor of 3. And we hopefully can see a couple of things here. One, that I have the square root of 3 over the square root of 3. And that is a factor of 1 that can simply cancel. The other thing I have is a perfect square of 4. So I can take the square root of that 4 and take it out of the radical sign. So far now I have 9 over 2 root 2. Now I don't want the radical sign in the denominator, so to get rid of that, remember we're going to multiply by a value of 1, so root 2 over root 2, because when I multiply these, the square root of a value times itself kind of undoes the squaring. And so in the denominator now, I have 2 times 2. The first 2 comes from there, and root 2 times root 2 is the other 2. And then in the numerator, I have 9 root 2. And so simplifying that, I get 9 root 2 over 4. There's nothing else I can reduce. I've got no fractions as a whole under the radical sign. I've got no perfect squares to take the square root of. And I've got no radicals in the denominator. So that is simplified. Now for mixed numbers, I'm going to choose to turn them into improper fractions first. So I, of course, do 3 times 7, which is 21, plus 3, and that's going to give me the square root of 24 sevenths times, and here I have 2 1/3, so I would do 2 times 3, which is 6, plus 1 is 7, so I get the square root of 7/3. Now I want to combine those as all one piece, and so that's really 24 times 7, or the square root of 24 times 7, over 7 times 3. So just kind of putting all the pieces together. Again, a step you don't necessarily have to show, but I like to kind of work through things there. Now at this stage, I can see that I have 7 over 7. So that is going to cancel. So now I have 24 over 3, or the square root of 24 over 3. Now 24 over 3 can be reduced. 24 over 3 is equal to so that reduces to 8. And if we think hard about the building blocks of 8, 8 is 4 times 2, or 2 times 2 times 2. But 4 is a perfect square. So I'm going to take it out of the square root sign there by taking the square root of it. And of course, the square root of 4 is 2, but then we've got that other factor of 2 still left inside. So this simplifies to 2 root 2. So the next one, we've got the square root of 3 times the square root of 6. And you could multiply that together. So just kind of showing 2 different methods here. I like to break them down, but you could just say, okay, this is the square root of 18. And then you want to think about what perfect squares you have there. And 18 can be broken down into 9 times 2. 9 is a perfect square, so you can take the square root of that, and that gives you 3. The square root of 9 is 3, and you have the root 2 left inside. So another way to look at it is you have the square root of 3, and then 6 is 3 times 2. And hopefully you can see the connection here, that 3 times 3 is that double, that perfect square. So you take one of them out as you take the square root, and of course that square root of 2 is left inside. So you can see you get the same thing whether you're looking at as pieces or just kind of some other building blocks. So I'd like for you to try the next one, the square root of 3 times the square root of 12. And either you're multiplying them together and then trying to kind of take the square root or break it down to its building blocks. Enter your answer on Edpuzzle, and then the video will continue and you can check. So how I worked this out was by taking the square root of 3, and then I broke 12 down into 3 times 2 times 2, or 6 times 2, and then I could see that I had 2 perfect squares. I had 3 and 2, and so that gave me 6. And so I've got the simplified answer of 6. For the next one, I've got this 2 root 5 times the square root of 7, and that gives me 2 root 35, and 35's building blocks are 5 and 7, so there's no pairing up there, there's no perfect squares there, and so that is the simplified answer. Sometimes there's not a lot to do. So for the next one here, we want to multiply the coefficients. And so 5 times 3 gives me 15. And I have root 3 times root 3, or root 3 times 3. That is going to either, you can see the double, or if you can't, if you're not noticing that, that would give me the square root of 9, or 15 times the square root of 9. 9 is a perfect square, so I really want to take the square root of it and take it out of the radical sign. And so that becomes 15 times the square root of 9, which is 3. And 15 times 3 is 45. And that's simplified. So the square root of 2 sevenths, we have the fraction. I always think it's a little bit easier to kind of think of it as its parts. So square root of 2 over the square root of 7. And those are both prime, so I don't need to break them down into factors. But I don't like the radical sign in the denominator. So remember, we want to multiply by a value of 1 because it won't change the value of the fraction, but it will change how it looks. Now, to get rid of a square root of 7, I would want to multiply by itself. So I want to multiply by the square root of 7 over the square root of 7. Again, this fraction has a value of 1, so it doesn't change the value of the expression. It's just going to change the way it looks. So now I have the square root of 2 times 7, or 14, over, and the square root of 7 times the square root of 7 multiplied by itself kind of undoes that square root. That just gives me 7. I don't have any perfect squares to take out of the radical sign. I don't have any fractions in the denominator, so this is simplified. For the next one, I have the square root of 5 over the square root of 15. Again, there's a couple of different ways you can handle it. If I break it down into its primes first, then I have the square root of 5 over the square root of 5 times 3. Again, I like to break things down so I can see what I'm dealing with, and hopefully you notice that you have the square root of 5 over the square root of 5, which is a factor of 1 and can cancel. Now what that leaves me with is a numerator of 1 over the square root of 3. I don't want the radical sign in the denominator, so I'm going to multiply by a fraction equivalent to 1 whole. In the numerator, then, I have the square root of 3, because the square root of 3 times 1 is just the square root of 3. And that square root of 3 times itself will undo the square rooting and give me just 3. So that is the square root of 3 over 3. Now that was not the only approach. You know, as I said, I like to break things down into primes, but you might not have done that. If you have the square root of 5 over the square root of 15, you could automatically say, hey, I want to get that radical sign out of the denominator. And then you have the square root of 15 over the square root of 15, and that would give you 15 in the denominator. And then you have 5 times 15 in the numerator, or the square root of 5 times 15 in the numerator, and that's the square root of 5 times the square root of 5 times 3, breaking that 15 down into 5 times 3 over 15. And the 5 times 5 is a perfect square of 25, and you pull that out and you get that root, that 5, so you would get 5 root 3 over 15, and then that 5/15 reduces to 1/3, and that's how we get back to that square root of 3 over 3. So you can see there's different approaches. Again, the more complicated an expression, the more ways there might be to simplify it. Make sure you bring your questions into class or put them in on Edpuzzle.